Hi, in this video I'm going to look at a confidence interval and what a confidence interval is and what it means. So when we go and do statistics, you go off and you collect a sample of data and you go and you get a bunch of scores, and one of the main things that people like to tell us once they've collected all of their data is they find the mean. And quite often they'll find the sample mean in this case, because we haven't taken the entire population, we've only sampled some of them, and we want to say how accurate is our sample mean a representation of our population mean. Now we could just go and say, well, our sample was taken fairly and equally, and so therefore we could say that our sample mean is the same as our population mean. But that's not generally good enough, because quite often it comes down to what your sample was. So let's just have a look at a situation. If I say draw in a quick number line, and I'm going to put 125 in the middle. I've just picked a number at random. So this is going to be my sample mean. I went and I got my sample mean. And I want to know, or I want to say this better than just saying my population mean is also 125. I want to say that it could be close to 125, but it's got a little bit of a margin of error to it. And that's where our confidence interval comes in. So I'm going to finish off this scale, and I'm going to say put in 124 down here, and I'll put in 126 up here, and break it up into 124.5 and 125.5, and we can have 0.75, 0.75, 0.25. Okay, and so now I've got a bit of a scale I'm just going to play around on, and I'm going to think, well, if I've got my sample mean here, this is going to be my sample mean, but how big or small around this do I want to push it? How big do I want to say that my margin of error is? So I want to think, how big is this margin of error? How far around my sample mean am I willing to go? Or how big is it? And so that's where we actually start thinking about what's going on. So let's think about the population distribution. If we generally, a sample or a population distribution is quite typically follows some sort of distribution. Normally it's a normal distribution. And so let's just say, for argument's sake, that my population mean was actually down here at 124.5 as a hypothetical. So this is going to be my hypothetical population mean. And if I think about this being a normal distribution, it means that my normal distribution is going to be around that hypothetical population mean following our typical bell curve. And I could go the other way. I could push a high-end hypothetical population mean. I could have a different one. What if it was out the other side? Okay, so I could have 125.5 for a population mean. And so that would mean that the bell curve here might look something like that. So I could think about how much either side do I want to push my hypothetical. And what we do is we look at what is the area underneath the curve of the bit where it actually sits in with our sample mean. And that'll give us the proportion or the probability of having something. If I think about my population mean being low, what is the proportion that I'm actually outside or above my sample mean? And there is a number associated with this. I'm just going to put 0.025 in there for now. And I'm going to put the same in here. What is the possibility, the proportion of my population that is below my sample mean if I take my hypothetical population mean to be high? And that is also going to be 0.025. What is my probability of being up there? And we can use this information to actually give us our error. And that gives us how confident we are, because error and confidence are converse. So if I think about this, I've got a total error within these numbers of 0.025 plus 0.025. I've pushed my means either side so that I've got this error where, well, my hypothetical population is giving me an error with my sample of 0.025. I'm outside of the range. And so that is a total error of 0.05. And so that means that I can work out a level of confidence, because that's going to be 1 minus my error of 0.05. And so that's going to be 0.95, or as a percentage, we would have this as 95%. And this is the most common confidence interval. It has a level of confidence of 95%. And that's where these numbers come from. So it means that my hypothetical population means being between 124 and 125 give me a level of confidence that I can say 95%, with a level of confidence, I am 95% confident that the population mean will be between these 2 points, 124.5 and 125.5. And so that gives us our confidence interval. So my confidence interval is this gap here between 124.5 and 125.5. That's our confidence interval. And we write that as an interval of 124.5, comma, 125.5. And so that means that we are reasonably confident, 95% confident, that based on the sample we obtained, that the population mean should be somewhere around 124.5 to 125.5. And taking it back to our margin of error, our margin of error is this gap here. That's what we call our margin of error. So in this case, our margin of error, which is sometimes told instead of a confidence interval, is 0.5 or plus or minus 0.5. So one way of reporting this is that the population mean is 125 with a margin of error of plus or minus 0.5. So that's two ways of reporting the same information. We can do a confidence interval and just say we are 95% confident that the population's between here, or we can say with a 95% confidence that the population is 125 plus or minus 0.5. And the last thing to point out with this, as you want to get more confident, so if you want to say that you're going to be more confident, so let's say that we want to have a level of confidence to be 99%. We want to be really accurate. I want to be 99%. Well, that means that our error has to be 1% or 0.01, which if we divide that by 2 is 0.005. So this little bit here has to be 0.005. And so that means if I have my sample mean coming down here, I've got to have my bell curve be such that it crosses that sample mean and only have a little bit of error under there being 0.005. And same with my upper hypothetical, it has to have under here this total error being only 0.005. And that pushes out our margin of error because it has to push the bell curves further left and right to make that happen. So if we want to be more confident and reduce our error, we actually have to say, well, I'm going to increase that, and maybe that'll be, we'll go back to 125, maybe we've got to be at 124.2 and 125.8 for our confidence interval. So we could have that our confidence interval is 124.2 up to 125.8. So that way we are 99% confident it's somewhere in this range. We've got a bigger range. Or we could say that the population mean is 125 with a margin of error of plus or minus 0.8. So we've pushed out our gap a little bit more. We've got a bigger gap here, or a wider interval, because we want to be more confident. But the only way to be more confident is to have a bigger margin of error. I've got to stretch out that interval and give us more range of options. And it goes the other way. If I only want to say that I want to be 80% confident, well, that means that I've got to have 0.4 as a total margin of error, and that means that I can have my bell curves be rather close in, because all of this can equal 0.2 and all of this can be 0.2. So it's quite a small, well, quite a big area here, but it pushes our confidence interval together. So maybe it could be 124.9 and 125.1. So that's what a confidence interval means. It's based on our sample mean, and I'm wanting to have a level of confidence of a certain amount. How far either side of that mean can I confidently say that the population mean is likely to sit?